Hey, all you cool cats and kittens, this is Mr. Rengel, and we had a request to do number 6 and 7 on section 8. So we'll take a look at those problems, and they both deal with a dartboard and looking at probability. So it says a target with a diameter of 14 centimeters has 4 scoring zones formed by concentric circles. The diameter of each circle The diameter of the center circle is 2 centimeters. The width of each ring is 2 centimeters. A dart hits the target at a random point. Find the probability that it will hit a point in the indicated region and show your work. So here, this is going to start to tell us the stats about the circle, which then are going to help us with finding the probability, because we have to compare the area of what we want to hit compared to the total area of the dartboard. So we're going to head into this circle a little further. So it does say that the diameter of this first circle is 2, this inside circle. So I'm looking right in here at this center circle. That's going to mean that the radius is going to be 1 right there. So that has a radius of 1, and then each circle, I'm going to switch to green because that's a red background, has a width of 2. So all these have 2. So we've got 2 plus 2 plus 2 plus 1. That's going to tell us that the full radius of this circle is going to be 7. Now, when you're finding a probability, anytime you find a probability, you're going to compare what you want to hit with your dart compared to the total region that you're trying to hit. So I'm going to show that off to the side over here. So find the probability first of, I should probably look at, we're trying to hit the center region. So to find the probability of hitting the center, I'm going to look at trying to find the area of the center compared to the area of the whole dartboard. So the area of the center compared to the area total. And both of them are circles, so we'll be using the circle formulas. Okay, so we start with the area of the center. Well, area of the center has a radius of 1, so the area of the center is going to equal pi times 1 squared, which gives us pi. So 1 times 1 is 1. 1 times pi is just going to still be pi. The area total, which I'm going to call area T, is going to equal pi times 7 squared. Which is going to equal 49 pi. Now you'll notice I'm keeping both of those in terms of pi. That's because when you multiply out by pi, it's going to always give you an irrational number, not an easy number to work with. We can compare the ratio of our probability with both of our areas in terms of pi. So again, we're looking for the probability of hitting the center, and that's going to equal pi over 49 pi. Well, you'll notice that since there's a pi in both the numerator and denominator, those are going to reduce out. So really, you're just looking at 1/49. So we'll head to our calculator, and we'll calculate that. Take 1 divided by 49. So we'd have about 0.02, so that would be a 2% chance of hitting that center circle. So my final answer is 2%. So I'm going to put both answers you can put as a ratio, 1/49th chance, which is equal to a 2% chance. So that would be number 6. Secondly, the blue region. So we want to hit the blue. What are the chances of hitting that blue region? So we'll show our work over here in blue. So our second problem, probability of hitting the blue. And again, that's going to be the area of the blue compared to the area total. So we already know the area total, so we got to work on finding the area of the blue region. So let's zoom back in and look at the blue. So this blue region is a ring right here. So if I included this whole piece as a circle, including the red and the white, I could find the area just by taking pi times 5 squared, which is 25 pi. But I don't want to include this area that represents the red and the white. Well, that would be a circle that's got a radius of 3. So I would find the area of this circle inside, the red and the white included, and then I'm going to subtract that from the area of the circle with the radius of 5. So we're going to show our work how we are going to work through that process, but it's using subtraction. So if we can find the area of the full circle of that blue ring, and then we're going to subtract out the area of the red and the white circle. So again, I have the area total. I'm not going to find that again. It's 49 pi. I'm just going to find the area of that blue region. So we're going to find the area of the blue is going to equal the area of the blue region, which has a radius of 5, minus the area of the red and white region, which has an area of, a radius of 3. So that would be pi. I'm going to go down here because I'm not going to have enough room. Pi times 5 squared minus pi times 3 squared. And again, the 5 squared represents the blue radius of all the way out to the blue ring. The 3 represents the radius of the red and white circle. And that's going to be 25 pi minus 9 pi, which is equal to 16 pi. So there's going to be the area of my blue region. Now, just like before, we'll take to find the probability of the blue, which I'm just going to use a capital B, is going to be 16 pi. That's the area of that blue ring compared to the total area, which is 49 pi. And again, the pi's will cancel, so we'll cross those out. So basically, it's just going to be 16 over 49. And we'll head in 16/49, so we'll head back to our calculator. 16 divided by 49 is going to give us 0.326, so that's 32.6, and since it's a 6, that's going to round up to 33%. So I'd have a 33% chance, 1 out of 3 chance of hitting that blue region. So hopefully this helps with numbers 6 and 7. Just a reminder, tonight we'll turn in sections 6, 10.6, 10.7, 10.8, and then next week on Tuesday we have our second quiz in chapter 10. Hope you all are well. Have a great day. Have a great weekend. Hope to see you soon. Goodbye.